It's like relatively easy, okay, compared to the 2D and 3D stuff that this Nobel Prize is going for. But there was a precedent to try and find these things, okay?
We are day 3 of Nobel Prize week, chemistry, and the winner is Metal Organic Frameworks.
So the chair of the Nobel Committee said, new rooms for chemistry that have custom sizes, custom doors, and they're made out of custom walls. So they've got a cartoon, as they always do. On the left there, that's the cartoon from the Nobel Committee.
Yes.
And on the right is the actual one of the examples. The idea is these things are exceptionally useful, mainly because they got a bunch of holes. Okay. For example, suppose you want to filter out carbon dioxide from exhaust, right? This porous material can now do that, right? Suppose you want to like get water from thin air. The porous material can now do that, right? So chemistry has been really good for a very long time with something called zero-dimensional chemistry, okay? That is localized, okay? Like small molecules, right? Those things are in some sense zero-dimensional because they're point-like, right? And that's a zero dimension.
Right.
Then we started getting really good at 1D, right? Polymers, that's a carbon nanotube. And we wanted to get to 2D and 3D, okay? But that was known as kind of a synthetic wasteland because it was really hard to figure out how to create stable 2D and 3D structures. 1D, you can imagine, right? You just like, you know, add like in a chain of like nerd, like, you know, those nerd ropes? It's like that. It's like relatively easy, okay? Compared to the 2D and 3D stuff that this Nobel Prize is going for. But there was a precedent to try and find these things, okay? There are these minerals that are found naturally. They're called zeolites. It was discovered by the Swedish mineralogist Alex Cronstedt in 1756. And what he did was he observed that like, if you take this material, right, which in this case it's stilbite, zeolite is the class of materials. What he discovered was this particular one. This thing could absorb water, okay? And then when he heated it up, steam would come out. Okay, very simple observation. But what does that mean? That means inside the chemistry, it's trapping water molecules, right? And then as you heat it up, those water molecules are going away in the form of steam. So what that means is there's some ability of this thing to absorb chemical compounds and then put them out, right? And there's like holes inside where this water molecule is going. Right. And that's why he coined it zeolite, because zeo is Greek for boil and lithos for stone. So it's like a boiling stone. And these zeolites became like a big passion of chemists because they're found naturally.